We hear it everywhere. Solar, wind, and hydroelectricity will power the future. These renewable sources are often hailed as the ultimate solution to our energy needs, promising a cleaner, greener world. But is it really that simple? These renewable sources are undoubtedly crucial. They harness the natural elements, converting sunlight, wind, and water into electricity without emitting greenhouse gases. They represent a significant step forward in our quest to reduce our carbon footprint and combat climate change. But are they the whole picture? Not quite. While renewables are essential, they come with their own set of challenges. Solar and wind energy, for instance, are intermittent. The sun doesn't always shine and the wind doesn't always blow. This variability can lead to instability in the power grid. The future of energy needs to be reliable, scalable, and safe. We need a diverse mix of energy sources to ensure a stable supply. This is where nuclear power comes into play. It offers a consistent and powerful energy output, regardless of weather conditions. That's where nuclear power, particularly a new generation of reactors, steps in. These advanced reactors are designed to be safer and more efficient than their predecessors. They can operate at higher temperatures and use fuel more effectively, reducing waste. Many still associate nuclear energy with the disasters of Chernobyl and Fukushima. These catastrophic events have left a lasting impression on the public consciousness, fueling fears about the safety of nuclear power. These events, while tragic, are not representative of the technology's potential. Modern nuclear reactors are built with multiple safety systems and fail-safes to prevent such disasters. The lessons learned from past incidents have led to significant advancements in reactor design and safety protocols. New reactor designs, particularly those using liquid sodium as a coolant, offer a level of safety and efficiency that surpasses traditional nuclear power. Liquid sodium reactors operate at lower pressures and have a higher thermal conductivity, which means they can transfer heat more effectively and reduce the risk of overheating. Let's delve into why this matters. As we transition to a more sustainable energy future, we need to consider all available options. Advanced nuclear power can complement renewable sources, providing a stable and reliable energy supply. By integrating these technologies, we can create a resilient and sustainable energy system that meets our needs without compromising safety or the environment. Traditional nuclear reactors use water to cool the reactor core and generate steam for electricity. While effective, water has limitations. It needs to be pressurized to remain liquid at high temperatures, increasing the risk of steam explosions. Enter liquid sodium. This remarkable metal remains liquid over a broader temperature range than water. It also doesn't need pressurization, significantly reducing the risk of explosions. This inherent safety feature is just one reason why sodium-cooled reactors are gaining traction. The term nuclear meltdown evokes fear and uncertainty. It's a scenario where the reactor core overheats, potentially leading to a catastrophic release of radiation. Sodium-cooled reactors, however, are designed to make meltdowns virtually impossible. Sodium's thermal properties are key to this safety advantage. If the reactor core overheats, the sodium naturally expands, slowing down the nuclear reaction. This passive safety mechanism, inherent to sodium's properties, eliminates the need for complex backup systems and provides an extra layer of protection. One common criticism of nuclear power is the time it takes to build new plants. Critics argue that the lengthy construction periods make nuclear power an impractical solution for our immediate energy needs. They point out that traditional nuclear power plants can take a decade or more to become operational, which seems too slow in the face of urgent climate challenges. While it's true that construction can be lengthy, this is changing. Advances in technology and project management are significantly reducing the time required to build new plants. For instance, the development of modular nuclear reactors, which are built in factories and then assembled on site, is revolutionizing the industry. These modular designs not only cut down on construction time, but also reduce costs and improve safety. Modular designs and streamlined regulatory processes are shortening construction timelines. Governments and regulatory bodies are recognizing the need for faster approval processes without compromising safety. By adopting more efficient regulatory frameworks, we can ensure that new nuclear plants are built and brought online more quickly. helping to meet our energy demands sooner. Furthermore, the urgency of our climate crisis demands immediate action. The effects of climate change are becoming more apparent and severe, with rising temperatures, melting glaciers, and increasing natural disasters. We cannot afford to wait decades for new energy solutions to come online. Immediate and decisive action is required to mitigate these impacts and transition to a more sustainable energy future. Waiting for renewable sources alone to meet our energy needs is no longer an option. While wind and solar power are essential components of a sustainable energy mix, they are not always reliable. Their output can be intermittent, depending on weather conditions and time of day. This intermittency poses a significant challenge for maintaining a stable and consistent energy supply. Nuclear power, with its ability to provide baseload power regardless of weather conditions, offers a crucial bridge to a cleaner energy future. Unlike renewables, nuclear plants can operate continuously, providing a stable and reliable source of energy. This makes nuclear power an essential part of the transition to a low-carbon energy system, ensuring that we can meet our energy needs while reducing greenhouse gas emissions. By integrating nuclear power with renewable energy sources, we can create a more resilient and sustainable energy grid. Interestingly, the nuclear resurgence isn't limited to a handful of countries. Around the world, nations are recognizing the role of nuclear power in achieving energy security and reducing carbon emissions. The United States is extending the life of existing plants and exploring new reactor designs. Japan, despite the Fukushima disaster, is restarting its nuclear program. Canada is investing heavily in small modular reactors. Even Germany, a country known for its anti-nuclear stance, is reconsidering its position. The renewed interest in nuclear power has significant implications for the uranium market. As demand for nuclear fuel increases, so too does the demand for uranium, the element that powers these reactors. This presents a unique investment opportunity. Uranium prices, while volatile, are expected to rise in the coming years. Investors looking for exposure to the energy sector should consider the potential of uranium. Several companies are poised to benefit from the uranium boom. Cameco, a Canadian uranium mining giant, is a major player in the market. Kazatomprom, a state-owned company in Kazakhstan, controls a significant portion of global uranium production. Beyond mining, companies like TerraPower, founded by Bill Gates, are developing innovative reactor designs. These companies are at the forefront of the nuclear renaissance, offering investors a chance to be part of a transformative industry. The future of energy is not a binary choice between renewables and nuclear power. It's a complex and multifaceted challenge that requires a balanced and integrated approach. We must consider the strengths and limitations of each energy source to create a resilient and sustainable energy system. It's about embracing a diverse portfolio of energy sources that meet our growing needs while protecting the planet. Solar, wind, hydro, and nuclear power each play a crucial role in this energy mosaic. By leveraging the unique benefits of each, we can ensure a stable and reliable energy supply that minimizes environmental impact. Nuclear power, particularly with advancements in sodium-cooled reactor technology, deserves a prominent place in this mix. These advanced reactors offer enhanced safety features, greater efficiency, and the ability to recycle nuclear waste, making them a vital component of our clean energy future. As we look to the future, it's crucial to separate fact from fiction when it comes to energy. Misinformation and outdated perceptions can hinder progress and innovation. By focusing on scientific evidence and technological advancements, we can make informed decisions that benefit both society and the environment. Nuclear power, often demonized and misunderstood, holds the key to a cleaner, more sustainable future. With proper regulation and oversight, nuclear energy can provide a reliable and low-carbon power source that complements renewable energy sources. It's time to rebrand nuclear power and recognize its potential to address climate change and energy security. It's time to embrace the potential of this powerful technology. By integrating nuclear power with renewable energy sources, we can create a robust and resilient energy system that meets our needs today and for generations to come. The future of energy is not about choosing one path over another, but about finding harmony and synergy between all available options. Together we can build a sustainable and prosperous future for all.